Hi, in this video we will learn about geometric meaning of dot product and its implications. It will have at least two important implications for us, orthogonality test and cosine formula. Okay, let us start with just what does that number u dot v mean. So if I have u and v, uh, one thing that can be done is that we can find projection of u on v. In other words, find the shadow of u over v. Then that shadow itself is a vector. Let me denote it by u prime. And the geometric interpretation is that u dot v is basically product of the length of u prime and length of v. But if you know the projection and how does it work, so you have a right triangle, the angle between u and v is theta, then basically what you will have on this side, in other words, the length of u prime is nothing but hypotenuse here, means that the length of the vector u times the cosine of theta, and then there was the v vector. Well, this means that basically u dot v, for u dot v, we have an alternative formula in which we don't use any components. We just use the length of u, length of v, and the cosine of theta, the angle between these two. One thing that I have to tell you here is that in this course we don't need to know the cosine table. We will only ask for the angle, not the angle itself, but the cosine of the angle between the vectors. So let's just use this formula and see how can that be a helpful formula. Example, find u dot v if the length of u is equal to 2 and length of v is equal to 3 and the cosine of the angle between u and v is equal to 1 over 5. Okay, with the original formula for dot product, we won't be able to find dot product because the original formula needs all the components of u and v. But with this new formula in hand, we can find u dot v just by multiplying the length of u to length of v and then multiplying it by cosine of the angle between these two. Length of u here is given, it's 2. Length of v is given, it's 3. And then the cosine of the angle between two vectors is 1 over 5. So what we found is that the dot product over u and v is 6 over 5 without knowing what are the components of the vectors u and v. Well, one of the very important implications of this thing is that, well, if I know this formula is true, I can divide u dot v to the other side. In other words, u dot v equals to length of u, length of v, cosine of theta. I can divide these two to the other side and write cosine theta is equal to u dot v over length of u times length of v. And that is the formula we will use, and we call it cosine formula. it says that if you know what is dot product of two vectors and their length, then you can find the cosine, cosine of the angle between those two vectors. U and then V. So let me just put this in a box so that you keep it in mind. Okay, well, before this we didn't have any such formula. We could not reach what is the cosine of the cosine of the angle between two given vectors. Now we can find the cosine of the angle. Find the cosine of the angle between the given pair of vectors. So if two vectors, one is 1, 1, and the other one is 0, 1, what is the cosine of the angle between these two? And then the second one is 1, -1, 0, and 2, 1, -2. We need to know the formula. So formula has the cosine theta is equal to u dot v in the numerator. So 1, 1 dot 0, 1, then divided by the length of 1, 1, and then length of 0, 1. That's it. So dot product, you know how to deal with that. The first component times first component, second component times second component, and add them. How about the length? Well, we square each component and then find the square root, add them and then find the square root, and that goes same for the 0, 1. And what we have is that 0 plus 1 over root 1 squared plus 1 squared is 2, 0 squared plus 1 squared is 1, and that gives us 1 over root 2. How about 1 and the other two vectors? So we have to find three things. 1, -1, 0 dot 2, 1, -2, and then the length of 1, -1, 0, length of 2, 1, -2. Well, dot product here is first component times the first component plus second component times second component plus third component times the third component. Then the length is square each component, add them, find the square root, and then same goes here. 2 squared plus 1 squared plus -2 squared. Then I have 2 minus 1 plus 0 over 1 squared plus -1 squared, it is 2. And then here 2 squared is 4 plus 1 is 5 plus another 4 is 9. So 2 minus 1 is 1. Root 9 is 3 and root 2 is just root. Just leave it like that. Yeah. So that is the new formula. As an important implication of that formula, you know that we know that cosine of 90 degree is 0. This is the only thing you need to know. That cosine of 90 degree is 0. That means that if two vectors are orthogonal, means that the angle between them is 90 degree, then u dot v is going to be length of u times length of v cosine of 90 degree. But cosine of 90 degree is 0, so it will multiply to anything else, it will make it 0. So if two vectors are orthogonal, their dot product is 0. And actually, the other way around is also true. That is, I am going to call it orthogonality test. Which says two vectors u and v are orthogonal if and only if there's only one thing you need to check to say if they are orthogonal or not. Find their dot product. If it is 0, that's it. They are orthogonal. So that is the second box I will put for you to keep in mind. We had cosine formula and we have this orthogonality test. For example, 1 and negative 2 and 3 is orthogonal to 2, 1, and 0. Why? Because when you find their dot product, you get, well, this is 1 times 2 plus negative 2 times 1, then plus 3 times 0. And that is 2 minus 2 plus 0 is 0. If dot product is 0, then you can conclude that those are orthogonal. That's the orthogonality test. And if it is not 0, they are not orthogonal. Let's just do one example on this, and then we go find values of k for which two vectors 1, 2k, and negative 1 and k plus 1, 2, and 3 are orthogonal vectors. So we have two vectors. Their components have some k in as number. So it says that for what values of k these two vectors are orthogonal. We know that they are orthogonal if and only if when you find their dot product, you get 0. Yes, but let's find dot product. What is dot product? 1 times k plus 1, 2k times 2, and then negative 1 times 3. You add them. This needs to be equal to 0. Well, let's simplify. This is k plus 1 plus 4k minus 3 needs to be equal to 0. So then we have this equation. 5k minus 2 needs to be equal to 0. So you can find value of k, which makes this one 0. It means that you isolate k is going to be 2 over 5. If k is 2 over 5, then 2k minus 2 is going to be equal to 0. Then this is going to be equal to 0, and that will go equal to 0. And that is the value which makes the two given vectors orthogonal. Okay, very quick wrap up. While we learn what is the geometric meaning of the dot product, we had 3 new formulas. One one cosine formula, and one orthogonality test.